Hello, students. It's Miss Naras again. We've been talking about how to get samples, how to make sure that the samples are representative and not biased. But what's the point? Well, once you have a sample, you want to use it to make an estimation or an inference about your whole population. We're going to do 3 examples of that today, and I'm going to show you a few different ways to do that estimation. Example 1 says, a survey found that 85% of people use emojis in their texts. Predict how many of the 1,010 students at a school use emojis. Think about how you might solve this problem. Well, you have a bunch of different options. One way would be to use multiplication. Now, I can't multiply 85% times 1,010 students, but I can multiply the decimal version or the fraction version of 85%. I'm going to use decimals. And then I'm going to multiply those two numbers together. And I get 858 and 50 hundredths. Now, the question said, how many students use emojis? So I'm going to round that and say about 859 students use emojis based on the sample. I don't know if that's actually accurate, but that is what my sample tells me. Now, it might not be super accurate because the survey says people, and I'm looking at students specifically, so it might be a little bit different because not all students have phones, but the ones that do probably use a lot of emojis, so it might be a little bit different. Let's do another example. 10 out of 30 students in Mrs. Hamachi's class have Instagram accounts. There are 540 students at their school. Estimate how many students don't have Instagram based on the sample. Think about how you might solve this problem. Again, I have many different options. I could write a fraction, I could use a decimal, I could find a percent, or in this one, I'm just going to use a proportion, another way to solve it. So I wrote 10 out of 30 equals x out of 540 since that's the whole school. And again, I have different options. I could cross multiply. I could use a pattern. I could simplify this fraction first. The way I did it was I figured out that I'm multiplying by 18, and then I did 10 times 18 in my head. So I get that 180 students have Instagram accounts. Now I have to be careful because, as some of you probably noticed, the question says how many students don't have Instagram account. Pause the video, do the math, and then hit play again. You should have gotten that 360 students don't have Instagram accounts based on the sample. Some inferences I can make. I could say most kids don't have Instagram accounts. I could say most of the, or only some of the students in the school have Instagram accounts. Let's do another example. Or this is a you try, one I want you to try on your own. Suppose it is 200 years in the future. The population consists of humans and robots. You collect a representative sample displayed in the picture. Take a quick look at the picture. Oh yeah, I see some humans, I see some robots. If the population has 13,500 members, estimate the number of robots in the population. Think about how I solved the other problems. What are my options here? And pause the video, see if you can do it on your own. Okay, I really hope you did it on your own. Let's get some answers. Well, I know my whole population, but now I will have to look at my picture to see how many robots and people there are in my sample. Well, there's what looks like 2 robots and 10 people total, or 10 members total. And I could use a fraction or decimal and use multiplication, or I can use a proportion, but either way, I should end up with the same answer of about 2,700 robots in this population. So some inferences I can make. There are more people than robots. And I see that in the sample, and I see that in my estimation of the whole population. Some other inferences I could make are 20% of the population are robots, or there is one robot for every four humans in the population. So, an inference is just something that I can say based on what the sample tells me. So, again, lots of ways to do it, but once you have your sample, use the information in the sample to make an inference and an estimation of what to expect in the whole population. Talk to you later. Bye.